Can you see the screen again?
Yeah.
All right, here we go. So I did all of that just to find the velocity. We know the velocity is 8 and we know the W is 2. And I kid you not, we need that for the next part. So I'm going to start the whole new problem. I'm going to do all of this again. Why am I doing all of this again? Because I need the velocity of B and the accelerate and the W to get the answer. So I'm going to do all of that and I'm going to say VB equals, I think it was 8, and I know it's going to be in the I direction. And W is going to be 4 in the K direction. Or was it 2? It was 2 in the K direction. You following me?
Yeah.
So now I know that, and I can use that to get my answer. Note something very important. You see how my answers are positive?
Yeah.
The answers are positive. That means that the guess that I made in the beginning was right. It means that VB is going to the right and that W is going in the clockwise. If either of those are negative, it just means that my guess was backward. That's all that it means. But the number itself is right. Okay? So that means that my assumption was right. That's all it means. Here we go. Easy peasy. All right. So now we got to find the angular acceleration. It's the same exact thing, except you have a different equation now. So here are our steps. Here's our method. 1, identify motion. If it's general plane motion in the beginning, it's general plane motion at the end. So identify. It doesn't change just because you're looking at acceleration. So I always like to draw my object separate from the problem because it helps me see it a little bit better. Especially for problems where you have multiple links, and you'll see that in the problem that I did. We know that this is general plane motion. All right. We know the acceleration, and I do my accelerations. I'll do them in green, whatever. We know the acceleration of A is going to be downward. And we know because of the same reasoning that B has to move to the left or right, that means that B has to be accelerating this way. Does that make some sense? Now, it's not always going to be that way, but it's going to be this way a lot of the time. So as long as you understand the reasoning for why I can assume AB is to the right, you're good. Okay? So we did that. That, I kid you not, dude. This part right here, for most students, I found for 50% of students, being able to do that part right there is the hardest part. If they can't do that, you can't get to the answer. So identify the motion. 2, write the equation. Now here we go. Now I got to explain the equation. So it's easy enough. Remember how if you have a particle going around an object, we know that it has, let's just take a focus on this real quick and we're going to turn this into an equation. We know it has a normal acceleration and we know it has a tangential acceleration, right? We know the tangential is equal to alpha times r. If you use the angular version, it's alpha times r, which is also equal to dvbt. All right, so it's all the same. We know the normal is going to be w squared times r, which is also happen to equal to be b squared over r. Make some sense?
Yes.
These are the particle version. And these, I like to say that these are the rigid body version. Make some sense?
Yeah.
It's the same exact
thing. But that W2 and that alpha, those are derivatives though.
No, they're not derivatives. Right. They're, yes, you know this. Alpha equals the derivative of W dt. But you don't need this. This is true, but we don't need it.
No, so I kind of do, because she, like, a lot of the times, like I can show you like a question right now where like finding the answer was literally taking like the double derivative, and I was so confused because it was like it was so easy, and then I was like, it was so easy, but then I was like, am I really getting the right answer? And I almost erased it, and she was like, you were right, and I just be like trying to fumble it. So that's why I'd be like, okay, I was like, my calculus is weak because she's very calculus centered.
Got you.
Sometimes like with the problems.
Okay, but then you need that then.
I was gonna ask you at the end. Yeah, that's what I was gonna ask you at the end if we could just go over those calculus things like really quick, because I get it.
That's not a problem. That's not a problem at all. But yes, no, you're right. That is a derivative. The alpha is dw dt. Make some sense? Yeah. Now, here's the thing. If you look at this, we have to write it like this. The whole acceleration is going to be the tangential plus the normal, right? That's the whole acceleration of the point. Watch this. I'm going to convert that into the equation that we need. The whole acceleration is the tangential plus the normal. What that means is the equation in acceleration form is like this. For translation, we're going to say that A equals dv dt. For rotation, we know that the rotation of an object, whenever an object is rotating, take a look at this. Right now, we're looking at these as two particles, right?
Yes.
And this one is sitting still. You see that? So we know the acceleration of this guy equals 0. If we put an arm between them, didn't I just make a rigid body?
Yes.
So basically, whenever an object is rotating around something, it corresponds as a rotation. And so what we're going to do is we're going to say that this right here, this whole term right here is a rotation about a fixed point. Make some sense? It's a rotation about a fixed point. And so we can literally write that equation right here for our rotation. So if it's rotating, then we can say A of the point that we care about equals, and it's going to be the tangential. And we know the tangential, is alpha r. But the thing is, we got to write it in vector form, right? So we're going to do alpha cross r. That's the vector version of alpha r. Well, this is the tangential. Make some sense?
Yeah, I'm sorry. Could you just repeat that one more time?
Yeah, no problem. All right. So the whole idea was we're gonna focus our mind on this. So we need the tangential piece. The tangential piece is actually equal. We wrote it earlier. The tangential piece is actually equal to alpha times r. And so if you focus your mind, if you focus over here with the equation that we're drawing up, we're going to equal, instead of writing as alpha times r as a vector, we have to write it as alpha cross r. So what I just wrote up is the vector version of what I had here. This is the scalar, and this is the vector. But they're the same equation. It's just that one's in scalar form, one's in vector form. So this represents the tangential acceleration. Then we got to do plus, and we need the normal acceleration, right? Because we know that that's the way it is. The normal acceleration is going to be equal.
But we're not using the translation one. Are we using the translation acceleration as well?
That's not translational acceleration. That's tangential acceleration, and that is a pain in the butt. There's no other way to write it.
No, when I say that, I'm talking about you know how you put that first equation there. You were just listing that. I'm just making sure.
Yeah.
That's what I mean.
Yeah.
A equals dv dt. We're not using that right now.
No, we're not using that.
Okay. Yeah. So I understand that A of t is the tangential.
Perfect.
And, plus A of n. Okay.
Now the A of n, we're going to use this w squared times r term, but we got to write that as a. Excuse me. We got to write that in vector format. Does that make some sense? I'm going to tell you like this. Do not wonder why. I'm just going to tell you, and it's going to make sense physically. That is going to be written as negative w squared times the vector r. Not w vector. W is a scalar. R is a vector. So what I'm going to do is I'm going to put the magnitude right here so that it doesn't mess you up, okay? This negative has to be negative. There's no other way for me to explain it other than me showing you real quick on a diagram. That has to be negative.
Nah, I understand that one because it's like it always works out mathematically in the equation, like common sense wise. I know that. I get that one.
Well, here's a visual. You're right. Mathematically, it always works out. But here it goes. Here it goes easy. The arm points toward the object, right?
Yeah.
But the normal acceleration points toward the reverse. And so because of that, the normal acceleration has to have a negative on it because it's going backward to the arm. So easy enough. You're exactly right. The normal acceleration uses the arm, but that arm has to be negative because we know it always points backward, always. And that is going to be our rotation equation. Make some sense?
Yeah.
Easy. So that's the rotation. For general plane motion, now I'm going to let you know this part right here destroys students. Do not ever forget to make that negative. Okay. So our rotation is going to have two terms. Our rotation is going to be made of two pieces in the acceleration. General plane motion is going to be the same exact thing. We just combine it. And so we're going to say the acceleration of the point equals, just like the velocity, we got to use the acceleration of the translating point, which is AA. Then we're going to do the plus, so this is going to be translating. Then you're going to do plus the rotation. Now the rotation is going to be the tangential, which is alpha cross r. And then you got to subtract the normal, which is w squared times the vector r. And so all of this is the rotation. You following me?
Yeah.
So it's literally very, very similar. If you look at the way that it was before, how I did over here, I did a rotation versus general plane. Now for, come on, zoom in. For rotation on a velocity, you have one cross product, and one translation. All right? It's simple. But for rotation on an acceleration, you have a cross product and the normal, because acceleration has two components to it. That's all. That's the only thing that goes different. Okay.
Mm-hmm.
And the general plane motion, you have the same thing plus the extra translation. So you're just adding one more term to it. Once you understand that there's one more term to it, everything else is exactly the same. All right.
Mm-hmm.
So from here, I'm literally just going to blast through it. But the reason why I kept going so hard about the reason why you need to find the velocity is because if you don't know W, you can't get the answer. That's all. Yeah. So once you know W, you're good. All right. So we did all our work to find W. We know W is 2K. Let's ride off into the sunset. So from here, everything else is the exact same. So we knew that. We know our equation is going to be, and I'll put it in green. The acceleration of B equals. Now here's the thing. Remember how earlier it's saying find the angular acceleration and the acceleration, right? A lot of students think that that's two different things. You see how earlier I found the velocity and the W? That same thing's going to happen. So we don't have to worry about thinking too hard. Just start solving. AB is going to be the acceleration of A. That's going to be the translation plus the rotation. The first part of the rotation is alpha cross R from A to B. All these rules are still the exact same, but you can't forget to do the normal acceleration, which is going to be W squared times R from A to B. Okay?
Yeah.
Now, we just do the same thing I did before. I can speed up a little bit because now you understand what I'm doing. AB. We don't know the magnitude, but we do know the direction. So I'm going to write it as AB, unknown magnitude, but it's going to go in the positive I direction. AA, we know the magnitude and the direction. And so we're going to go at, what was it, 4? It was 5. It was 5. My bad. It was 5, but it's going downward. So we're going to put a negative on it. Okay. Then we know alpha. Alpha, it works the same exact way as W. So we don't know the magnitude, but we do know, we're going to assume that it's positive K. Okay. We know the arm is the exact same. RAB is the exact same as before. It does not change. So it's going to be 3I minus 4J, if I'm not mistaken. And then we're good from and because W is 2. So whatever. And you do the exact same thing. So all you got to do is tie it all together. AB is not going to be AB in the I direction. So just make sure you have enough space. Like you're going to use all of this space just because it gets long. That's all. Especially when you start using cosine and sine. And I'll show you a problem really, really quickly at the end of this. So AA is going to be negative 5J. Alpha is going to be plus, and then it'll be alpha K. Cross the arm, which would be 3I minus 4J. And I'll put a double parenthesis to make sure I don't mess that up. Minus W, which is 2 squared. And then the arm, which is 3I minus 4J. Bam, I just filled it all in. Make some sense?
Yeah.
So this guy goes to him, this guy goes to him, this whole thing goes to him, and this whole thing goes to them. Bam, 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 bam. I promise you do. My real question is, do you understand everything about how I built this equation?
What do you mean by do I like understand how you built it? Like how or like why you built it that way?
Like why? Like because this is the equation always. This is always the equation. But do you understand like how I got each and every what they mean?
Yeah, so I understand. So I understand because that 5J was given and it's in the J direction because it's
Hmm.
going down and it's negative, right? I understand that. Then you, like you said earlier, you also have to have the acceleration in the normal and tangential direction. And so that equation that you have there, you don't have, I guess I forget if that's alpha. I don't think you have that yet fully. So
Hmm.
you put that there as a regular variable times the 3i minus 4j, which is
Hmm.
that RAB, and that's the directions in it. That's why you have the vector I and j there,
Yes,
minus the tangential direction, well, tangential acceleration, which is that W squared. And then you also have that directional output there, that RAB, because that's the direction that it's going in.
exactly. Good, good, good. So everything else right here is literally plug and chug. And so let's just do the cross product. I'm gonna do the cross product above real quick because I can do that. It's gonna be 3 alpha. K cross I is gonna be positive J. And then it'll be 4 alpha. And then K cross J is gonna give me negative I, but I have a double negative. Okay. And then this right
Mm-hmm.
here is gonna give me, I just put a plus here, a minus there, and a plus there. That's what I do. I just flip the variables so that I
Mm-hmm.
don't mess myself up. Okay. So
Mm-hmm.
AB I equals negative 5J plus 3 alpha in the J. And then I'm going to do plus 4J because this 4J came from here.
Mm-hmm.
But then don't forget, I almost messed up. And you're going to see a good thing is I'm messing up so you can see where students mess up. Don't forget the 4. It's 2 4s. 2 squared is 4, and then another.
Yeah, I wasn't gonna say that, but I didn't know if that was different because the alpha that was applied. So I was just
No,
gonna
I
say,
legit just messed up, and that's fine. People, it doesn't matter how good you are, you're gonna mess up, and it's always like for my students to see when I mess up, because if I mess up right there, you're probably gonna mess up there as well. So just so you can catch those mistakes. So I got all my J's, and then I'm gonna need my I's. So my I's are gonna be for alpha in the I, and then I got a minus 4 times 3 in the I. Cool. So I broke everything into my pieces.
mm-hmm.
Now, what's my last step? Now everything is the cross products are good and all that stuff, and this is what I'm left with. What's my last step? How do I get my answer?
Combining the I's and J's, I'm assuming, like solving form.
Well, you can't combine the i's and the j's because they're different directions.
I mean, I'm saying like each respective one is what I mean, kind of. Or am I wrong
No, okay. So
about
where you're
that?
where you're going is in the right direction. When you say each respective direction, how do I get each respective
Mm-hmm.
direction? Because how many equations do I need? That's the real question.
Uh, two equations,
There
because
you
you
go.
have, well, you need one, yeah, two equations, and you have two unknowns because you
Mm-hmm.
don't know what alpha is, and you don't know what the acceleration in that direction, and that acceleration I think that's an I, if I remember correctly, right?
Yep, it's I.
So you're going to take all the I's that refer to that, I'm assuming.
Yes, exactly. Exactly. Take all the i's, AB equals, and then I just do my 4 alpha minus 12. So that's one equation. Where's my second equation?
Um, uh, uh, Alpha,
Alpha where?
which is alpha, which alpha? The four alpha. Oh, no, 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 no. The three alpha because it's in the J direction.
Mm-hmm.
Because you already used the four alpha, right?
Yeah,
So
I
you would
already
use
used all
the
of this right here. All of this right here just got used. So I
yeah,
got to use the other side.
yeah. I just noticed that. So then you would use that three alpha. You would use that three alpha J, right? So you would have rho is equal to I feel that one is kind of confusing
It's tricky, right?
just because I don't. Yeah, a little bit.
It's all good. This is what we're gonna do.
So,
We're gonna refer back so that you can get your mind right. So what we're doing the exact same things before. Once you build the equation, there's
hmm
nothing different. So let's refer back to what we're doing over here, and I'll put it in green, whatever. This is where we are, basically. This is where we are in the acceleration problem. where we had the whole thing written out with all the W's, the V's, the I's, and the J's. And you see, I put the little star because I said this is the
Oh,
hard
so
part.
so yeah, set it equal to 0 then. Let's set it equal to 0. I
Exactly.
see that now.
You got it. That's all it takes is to refer back to how you do it with the velocity. On the left side, you have equal to 0. And then
why
on the
do
right
but
side,
why do we set it equal to 0?
because
Why do we set it equal to 0?
AB only is in the I.
Mm-hmm.
There is no J component.
Okay.
Now, there are going to be
see that.
problems, though. There are going to be problems where there is a J aspect to the AB. And so you're not going to have a 0. You're going to have whatever the J is on it. Does it make some sense?
Yes. Okay.
And that's going to be the only difference. So that's just going to be pure math. So sometimes you're going to have it, AB is going to be I, and there are going to be problems where AB has I and J. And so because of that, you're going to do the I part in the first part. You're going to call it ABI. And then the second one, you would call it ABJ. But in this one, we don't have that, so we don't have to put all of that. Make some sense?
Yeah, I think I'm just not recognizing that whole first equation had all J's. I didn't realize that at first.
But now you got it. Cool.
I didn't recognize how you separate it. Yeah. Mm-hmm.
And so all you're saying is this is just a lot of habits that I built because everything in this class has a foolproof way of doing it. Everything, period. There is no, some people get it and some people don't know. That's wrong. Everything in this class, there's a way to do every single problem in school, period. It's just that you have to know how to do it. You have to know how to think about it. And so this is my way. I do this every single time. And it seems like it's taking a long time now because I'm talking. But I'm gonna just draft up a problem and I'm gonna fly through it in like 5-10 minutes, and you'll see how fast you can do it once you've practiced it. Make some sense?
Mm-hmm.
So all we got to do is solve both equations. This one's going to give me
11 over 3.
Yep, negative 11 over 3, which means, and all this means is that my answer was backward. That's all. So it's not actually rotating clockwise; it's rotating counterclockwise. So when they say what's the actual vector, there, so you can say alpha equals 11 over 3 in the negative k direction. That's all you got to do.
Mm-hmm.
Okay, so alpha is negative 11 over 3, but you're going to plug it in exactly how you see it. So whatever, if you got negative 11 over 3, you got to plug that in as a negative. So this is going to become AB equals negative 4 times 11 over 3 minus 12. AB equals, and that's going to be negative 44 over 3 minus 12 becomes 36 over 3. That's going to be negative 80. Yeah, 80 over 3. And that's going to be my answer. Okay. Now here's the thing.
Mm-hmm.
A lot of students wreck this. They go, but my answer says that my object is moving backward. They think that this means that it's moving to the left.
Mm-hmm.
It doesn't mean that it's moving to the left. It means that it's accelerating to the left, which means it's slowing down. Does that make some sense?
Yeah, I seen that in your book. There's 3 like